A very good morning, all of you. Firstly, thank you all for subscribing to my channel. Finally, I have got 300 subscribers. So I thank each one of you to for subscribing to my channel and encouraging me, like motivating me, and telling me in an indirect way that I can actually make videos further without any hesitation. There are two reasons why I am not making videos continuously. First reason is that I am very busy with my project work and it is at the end, and I am telling you that after few days I'll definitely start making concepts because it's almost done. It was a 1 year project and now it is in the submission process. So as soon as I complete that thing, I'll definitely start making videos. Second reason is that I did not share with you people that this channel was a very random idea. Like one day I was just wasting the whole day, so I just felt bad about myself that why am I wasting my time like this. So I thought that making a channel will make me little busy and make me focused on my studies for the entrance preparations. So as soon as I got that idea, within an half an hour, I uploaded my very first video of the formula. If you remember, I did not have any idea about what should be the channel name, how am I going to take my channel. Without thinking anything, I started my channel. So that is the biggest reason that why I am not able to make videos. As soon as you are requesting me something, why am I not making to make them, is that I have not prepared anything. I have to prepare, I have to collect many books and all. So it will take some time for me to do all those things. Till then, I request you to please follow the like what am I planning is I am planning for questions most of the time because these are easily available. So I request you to please follow this channel for few days. Try to cooperate. I'll make even the conceptual videos. Till then, do follow the channel for the previous CSIR questions. Okay. So today we'll discuss two questions. Three questions from previous 2017 CSIR. Two of them are your regular questions and one will be a question of the day. Okay. So the compound N2F2 has two isomers. Choose the correct option from the following. So what all you have to know, the structure of N2F2. You are given with the four options. First, just write the structure of N2F2. So N2F2 has two isomers, that is a cis and trans isomer. Okay, and N2F2, N double bond N F2. Okay, this is all is the structure of N2F2. Now if you look carefully, how does the structure resembles? It resembles like your H2O2, cis H2O2. Okay, and most of us know that cis H2O2 has C2V point group. As the structure is similar to a cis H2O2, this is also the C2V point group example. Now how is it C2V? You have to pass a axis through this particular bond. Okay, if you pass an axis through, if this is N double bond N, you have a fluorine here, you have a fluorine even here, in this way, then you can pass a C2 axis through these particular bonds. So this is your C2 axis. Along the same bond, you can have a plane. You can have a plane such that this fluorine will reflect this particular fluorine. Okay, and then you have a molecular plane. Now where is the molecular plane? This is your molecular plane. What does the molecular plane do? It cuts all the atoms which are present in this particular molecule. Now as this is your axis, as this is your axis and this is your plane, so axis is perpendicular, is parallel to the plane, hence it is a vertical plane. If the axis is perpendicular to your plane, then it is a horizontal plane. Okay, so if this is your, these are your two bonds, this was your axis and this is your plane, then it is a vertical plane. And next I have told you molecular plane. How is the molecular plane? Even the molecular plane is passing through this direction like this. Okay, as this is the molecular plane and it is parallel to your axis, principal axis, this is the axis and this is also a molecular plane. So you have a sigma v dash. This is also a vertical plane but not horizontal plane, as this is parallel to your axis. Okay, and this was your another plane over here and this was your axis, as I said. So there are two planes, one axis, and E is anyways there in every molecule. So what is the point group? It is C2V. So N2F2 has two isomers. One is cis isomer, and one isomer has a particular sigma V plane. With that, what can I say? That option B cannot be your answer, because both isomer possess sigma H, but we have seen that this isomer do not have sigma H. It has two sigma V's only, and none of them have a sigma H. Okay, we cannot eliminate this, but yeah, none of them have a sigma H plane. Okay, fine. We can eliminate B option because these do not have a sigma H plane. Okay, now we'll go for the trans isomer. Now how is the trans isomer? Trans isomer is similar to your uh, trans H2O2. It is same as that, right? It is same like that. So again here, what is the axis? Here is your C2 axis. If it is N double bond N, if you have a fluorine here and you have another fluorine here. So if this is the structure of the molecule, something like this, right? So you can pass a axis over here from this particular bond. You can pass a axis like this. So if you pass a axis like this, what happens is inversion will take place. This particular fluorine will come here, and this particular fluorine will come to this side. Okay, there will be exchange between these two particular fluorines. Hence we can say that this particular molecule has a C2 axis. And now this was your axis. Okay, this was your axis, and in the same direction you have a horizontal plane, that is sigma H. You have a horizon. If this was your axis, you will have a horizontal plane, or what can I say, is it, yeah, horizontal plane will be in the same direction as that of axis. So as it is in the same direction, am I going wrong? I'm sorry. Okay, so this is your C2 axis. So this was your molecule. Okay, this is your C2 axis. Now horizontal plane will be in this particular direction, which will pass from your fluorine to carbon atoms and this particular fluorine. Okay, so forget this. This will be your axis. Okay, and as it is perpendicular to your principal axis, you can tell that this is your sigma H. Because what is sigma H? When an axis is passed in a direct when a plane is passed in a direction opposite to your axis, then that is your horizontal plane. Okay, and you have a E. What else you have? You have I, because if you pass an axis, if you try to join the opposite points, it will meet at one particular point, and that is nothing but your inversion I. Because I hope you understand, I don't have to explain in detail, right? You have a I in this particular molecule. So this is your C2H point group. And what is the plane present here? Sigma H. So what is the correct option? One isomer has sigma H plane and other has a sigma V plane. Okay. Next particular question. Addition of NaBH4 to this particular complex will give what? Okay, first let's try to write the structure of this particular given complex. Iron, neta 5, neta 6, and a plus charge is given. Okay, and you have to add NaBH4. Now how do you add this particular NaBH4 to this given complex? Okay, so what are the rules followed here to write the product? It is here DGM rules, that is Davies Green Mingo's rule. According to DGM rules, even is greater than odd. It means the addition is preferred over even compared to odd system, and it is preferred over open than closed, and it is preferred over terminal than internal. Now this last thing is applicable only when you have a open structures over here, but both are closed. Now this is a closed system, this is also a ring, that is closed system. So closed is here, there is no open, so definitely these two are not satisfied. And now you have even and odd. Among even and odd, where the nucleophile, that is H minus, will go and add, according to DGM rules, it will go to even carbons. Okay, where are even carbons present? It is this particular ring. So where the hydrogen will add not to this particular pentadienyl ring, but instead it will add to your this ring. Okay, the hydrogen will come and add over here, right? So what is the right option? Right option is this. Neta 5 Cp is as such, iron is as such. Neta 6 Neta 6 C6H7, because one hydrogen is added over here. So this is your right answer. Option D is your right answer. Okay, coming to the question of the day, it is from your bio inorganic, and the question is to consider the following statements for deoxyhemerythrin and deoxyhemocyanin. They are involved in oxygen transport in biological system. They contain two metal ions in their active sites. Active site metal centers are bridged by amino acid residues. They prefer to bind only to one oxygen per active site. Now you have to know the structures to just answer these questions. Now this is the structure for your deoxyhemerythrin and this is your deoxyhemocyanin. Okay, now we know that hemoglobin, hemerythrin and hemocyanin all are oxygen transport proteins. So these two are definitely oxygen transport proteins in your biological systems. So A is your right option. They contain two metal ions in their active sites. If you look at the structure, here there are two iron, here there are two copper present. Hence even option B is your right option. Active site metal centers are bridged by amino acid residues. Now if you look at this structure, these are your active sites, but this is hexa coordinated. Okay, so on addition of oxygen, where will the oxygen bind? The oxygen will bind over here. Okay, this is your active site and active site will bind over here. Okay, so as oxygen will bind to the iron FeB over here but not amino acid, hence you can tell that option C is wrong just by considering this particular diagram. You don't have to go till here also. Still here also oxygen binds to the active metal centers on addition of oxygen but not amino acid. So C is your wrong option. Okay, they prefer to bind only one O2 per active site. Yes, here O2 will bind over here and here also one oxygen, that is O2, is binding to your active site. So what is the right option? A comma B comma D. Apologize for mistakes I have done, but I have clarified wherever I have done mistakes, like here, yeah, here, not here but here. Yeah, this was your axis. If this was your, if this is your molecule and if this is your axis, and then the plane is perpendicular to your axis. Okay, thank you.